So today we're looking at section 8-5, factoring a trinomial in the form x squared plus bx plus c. So today you are going to write trinomials as the product of two binomials. Okay? Now, in order for us to do that, we need to find two numbers that have a sum of b and the product of c. So here's b, so the sum of b and the product of c. So you can pause the video now and do a little bit of your reading notes and catch up on writing some of the things that you need to write on this slide. Okay, problem 1. Problem 1 says factoring x squared plus bx plus c where b is greater than 0, which means that b, of course, is positive, and c is greater than 0, also positive. Okay? Now, in the text you will see that one way for you to organize your factoring, is to use a table to list the factors of your constant term c. Okay, so we're going to use a table, and I'm going to show you a way to organize your information called the X method. I just call it the X method just because I just put the information on an X. Okay, so we want to factor r squared plus 11r plus 12. Okay, now it says here that when we are factoring, when we multiply, we want to get our c term. So that's going to be a positive 24. When we add, we want to get a positive 11. So what numbers can I multiply to get 24? Well, there's 1 times 24. There's 2 times 12. And there's 3 times 8. So now we need to think, once we have all of our factors, now we have to think which one of these pairs of factors that when I add them, which one will give me my b term, positive 11. Okay? So here, let's see, 11 plus 24, that's 25. 2 plus 12, that's 14. 3 plus 8, 11. There it is, right there. So that means that we're going to use a positive 3 and a positive 8 as our binomials. So in our X method, I'm going to write positive 3, positive 8. So that tells you how you're going to write it in the binomial form. So here's your binomials. And to get your first term there, you're going to get r squared. So that's going to be r times r. And then for the second term, we already checked it over here. So we're going to write plus 3 and plus 8. And again, just to double check our work, we can check our inner term and our outer term. So our inner term is 3r, positive 3r, and our second term is positive 8r. So when I add 3r plus 8r, r plus 8r, that's going to give us 11r, which is what we were looking for. So this is your final answer. Okay. So you can pause the video and review problem 1 if you need to, or let's go on to problem 2. So problem 2 says, let's see here, some factorable trinomials have a negative coefficient of x and a positive constant term. In this case, you need to inspect the negative factors of c to find the factors of the trinomial. Well, why is that? Well, let's see. Because when we are multiplying, okay, when we multiply, we want to get a positive 8. And we know that if we multiply a positive times a positive, that's going to give us positive. Also, if we multiply a negative times a negative, what's that going to give us? Yep, a positive. So that means that we have to look at the positives, we have to look at the negatives. But the other thing that we need to remember is that when we add them, we want to get a negative b term. So if I add a positive plus a positive, am I going to get what I want? Am I going to get that negative? No, I'm not going to get a negative. So I can just now throw out that I don't want to look at any of the positives. If I add a negative plus a negative, isn't it true that I'm going to get a negative? Yeah, that's true. So we want to find our factors, and we're going to do a negative and a negative of 8. Okay? And again, I'm going to use my x method as well as using this table over here. So when we multiply, we want to get a positive 8. And when we add, we want to get a negative 6. So let's see, what are our factors of 8? Well, we have 1 times 8 and 2 times 4. And that's it. Because if you do 4 times 2, that's the same thing. So just 2 times 4. You don't have to write 4 times 2. Now, we want both of them to be negative because of what we previously discussed. So if they're both negative, and now we want to add, what will we get when we add them? So here we're going to get negative 1 plus negative 8, that's negative 9. Negative 2 plus negative 4, that's negative 6. That's the one we want to get negative 6. So these are the two factors that we're going to use in our binomials. So we have negative 2 and negative 4. And now we can put this in as the product of two binomials. So we want y squared, which is y times y, and then we can bring our binomials in, negative 2 and negative 4. And then, of course, we can check it. So here, negative 2y plus negative 4y gives us negative 6y. Negative 2y plus negative 4y equals negative 6y. So we are correct. So this is your final answer right here. There's your final answer. Okay? And again, right here where it says, why look at pairs of negative factors of 8? Well, we just answered that already up top. Only two negative numbers have a positive product and a negative sum. Okay, negative plus a negative is a negative. Okay. So you can pause your video so that you can review what we just did, or you can move to problem 3. Okay, so problem 3 is factoring where c is less than 0. And of course, when we have c is less than 0, we all know, what does that mean? That means that c is negative. Okay? Now, when you factor trinomials with a negative constant term, you need to inspect pairs of positives and negatives of C. Okay? Now, the reason that we do that is because we know that when we are multiplying, okay, if we want to get a negative, when we are multiplying, we want to get a negative, that means a positive times a negative. So that means that we want, oops, that means positive times a negative is a negative. So one of our factors has to be positive, one of them has to be negative. And then when we add, we have to remember that when we're adding two numbers, two integers with different signs, we subtract the digits and take the sign of the higher number. Okay? So we have to take that into consideration when we are adding. So let's take a look at our x method. And again, when we multiply, we want to get a negative 36. When we add, we want to get a positive 9. So now we have to look at the factors. What are the factors that will give us negative 36? Okay, so I'm just going to write down the factors of positive 36, and then we'll put the negatives where they need to be. So let's see, 1 times 36, 2 times 18, 3 times 12, and 4 times 9. Okay? Now, which one of these, okay, remember we want to have one positive and one negative. One positive and one negative. If I have a positive 1 and a negative 36, that's going to give me negative 35, right? So that's not. If I have a negative 1 and a positive 36, that's going to give me a positive 35. So this one's out. If we have a positive 2 and a negative 18, when we add positive 2, negative 18, that's going to give me a negative 16. Well, if I have a negative 2 and a positive 16, that's going to give me, a positive 18, that's going to give me a positive 16. So that's out too. For 3 and 12, if I have a positive 3 and a negative 12, that's going to give me a negative 9. If I have a, so that's not right, This one, nope, that's not right, because we want to have a positive 9, right? So let's see, we have 3, let's have a negative 3 plus a positive 12. That's going to give me a positive 9. Is that what I want? Yes. So that means that 3 and 12 are the factors that we're gonna use. So 3 and 12. And again, we want to have a positive 9. We want a positive answer, so we have to take the sign of the higher number. So that means that the 12 has to be positive and the 3 has to be negative. So now we can put our trinomial in the form of the product of two binomials. So n squared, n times n, and then we can bring in our binomials. So negative 3 or minus 3 and plus 12. And then again, we can check it. So inner terms, negative 3n, outer term, positive 12n. So that is going to give me positive 9n, negative 3n plus 12n, that equals 9n, and that's what we want. So our answer is correct. Okay? So why don't you pause the video and try letter B on your own. Okay, go ahead and pause the video. and try letter B on your own. Okay, so let's use our X method. Oops. Let's use our X method to factor this trinomial. So when we multiply, we want to get negative 21, and when we add, we want negative 4. So we're going to write down the factors of 21. So 1 times 21, 3 times 7, and that's it. So one's got to be positive and one's got to be negative. Well, we know that 1 and 21 is not going to work. So here, the 3 and the 3 and the 7, that's going to give me 4. But I want to have a negative 4, right? So which one of these has to be positive, which one has to be negative? Well, the 7 has to be negative, so that when I add, I get negative 4. Okay? So those are our factors. So we're going to use positive 3 and negative 7. So now we can write our trinomial in the form of a product of two binomials. So c squared is c times c, and then we're going to write our binomials here, our factors into the binomial. So that's going to be plus 3 and minus 7. And then again, you can check. So 3c, that's positive. That's our inner term. Our outer term is negative 7c. And when we check that, that's going to be a positive 3c plus a negative 7c. Oops. 3c, positive 3c plus a negative 7c or minus 7c. And that's going to equal negative 4c, which is what we wanted. So our answer is correct. There's our final answer. Okay? Problem 4 is applying factoring trinomials. Here, a rectangle's area is x squared minus x minus 72. What are the possible dimensions of the rectangle? Now remember, when you are finding the area of a rectangle, the formula is area equals length times width. Okay? So when we have our rectangle, we want to know what is, in order to find our area, we're going to multiply the length times the width. So that's something times something. Now since this is a binomial, we can factor, this is a trinomial, we can factor the L and the W into two binomials. And again, we'll just do that just like we did in problem 1, 2, and 3. So here we're going to use our X method and our table if you need it. I'll just do my table on the side. So when we multiply, we want to get negative 72. When we add, we want to get what? What's in there? Yes, negative 1. So we want to add, when we add, we want to get negative 1. So now we have to write the factors of 72. So 1 times 72, 2 times 36, 3 times 24, 4 times 18, 18, okay. 6, 6 times, let's see, 6 times 12, good. And then 7, 8 times 9, and because you can't have anything anymore in between 8 and 9, then you're done with your factors. Okay? Now, again, because we want a negative number when we multiply, that means, remember when we talked about that in previous problems, we have to have one positive and one negative when we multiply to get a negative. Now when we add, we want to have a positive 1. So that means that when we add, we want to get a positive 1. The bigger number has to be negative, and when we add them, we get 1. Okay, let's see here. Which one of those? Nope. 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 Bingo! There it is. So we have an 8 and a 9. Now, which one's positive and which one's negative? Well, we want the answer to be negative, so the bigger number has to be negative. So we have a positive 8 and a negative 9. So when we rewrite using our binomials, our x squared becomes x times x, and then we can put in our factors, so plus 8 and minus 9. And there's your final answer. One of them could be the length and one of them could be the width. And either one would be the correct length or width because multiplication has the commutative property. Very good. All right. Let's take a look at problem 5. Now problem 5 is throwing in a wrench here. You can also factor some trinomials that have more than one variable. Consider the following product here. We have p plus 9q times a quantity p plus 7q. Okay? When we look at foiling here, there's my first term, p times p. That gives me p squared. Okay? The outer term, first outer, so that's p times 7q. P times 7q gives me positive 7pq. Then we have our inner. That's 9q times p. There it is, positive 9pq. And then finally our last is 9q times 7q. There it is, 9q times 7q, which gives us 36q squared. Now when you look at this, okay, this suggests that a trinomial with two variables may be factorable if the first term includes the square of one of the variables. So let's see, there's my first term. I have p's and q's. There's my first term, p, s. Then the middle term includes both variables. So the middle term has both a p and a q. Yes, it does. Good. And then finally, the last term includes the square of the other variable. So the first one was p, the second one is q. There's my q. And it's squared. Good. All right. So here's problem 5. And I don't want you to get freaked out because I only have, I think I have too many spaces in this table, but it doesn't matter. Okay? So let's factor a trinomial with two variables. Okay? Why does that keep going up? Okay. All right. So let's use our x method again. Our x method and the table. So when I multiply, I want to get a negative 27. When I add, I want to get a positive 6. Now, remember, when you multiply, a positive times a negative is equal to a, negative. So that means one of the factors has to be positive, and one of the factors has to be negative. So let's write our factors of 27. we have 1 times 27, 2, no, 3, yeah, 3 times 9. Anything else? Nope, see, I had some extra spaces in there. Okay, so which one of these that when I add them will give me a positive 6? Well, let's see, this, if I add those, that's going to be, and keep them both positive. Let's make negative and negative. So this is going to be positive 26. Nope, that's not it. Here, negative 3, positive 9. When we add it, what are we going to get? Positive 6. There it is. We lucked out. We got the first try. So those are the factors that I'm going to use in my binomial. So we have negative 3 here and a positive 9 there. So now we can write them as a product of two binomials. Now remember, we have two variables. We have an m and we have an n. The m goes on the first term, so m times m, m squared. N times n is n squared. And now all we have to do is put in our factors. So minus 3 and plus 9. And there's our final answer. If you want to double check, there's our inner. So negative 3n times m, negative 3mn. Remember, they do it alphabetical. And then m times positive 9n gives us a positive 9mn. And then if I have a negative 3mn plus a 9mn, that's going to give me a positive 6mn. So yes, I am correct. And that's problem 5. And here is your homework. Page 503 to 504, 11 to 39 odd. I hope you liked your first video.